All right, I just wanted to say a few words about this problem. This one can really throw students for a loop. So make sure you read it well. What we have going on here, it's a cool situation. That's why I keep presenting this problem year after year to students because I think it's so good to think about. This is a case where there's no friction at any interface. Okay, there's no friction at any interface, but it's not a simple problem. You have a wedge there, and the interface between the wedge and the surface beneath it is a frictionless interface. And then there's a block that's placed on that wedge, okay? And there's also no friction at the interface between the block and the wedge. So everything's slippery, like there's no friction anywhere in this problem. So first kind of try to imagine that. That's harder to imagine because it's not the world we live in. And the question is asking us, what must the magnitude of F be? There's a force applied to the wedge. Okay, look at that force. It's applied, directed to the right, applied to the wedge. What must be the magnitude of F if the block is to remain at a constant height above the tabletop? Right. So you can kind of, like for me, I can imagine this happening, right? But then I really have to stop and kind of unpack what are all the forces that are going on here. It's a neat problem, so I would really encourage you to spend time on it. One of the reasons I introduce it is just to tell you that yes, this is really the situation. You're not missing anything. And the other is be really careful when students see this problem at first. They see an incline, and they will automatically just kind of on autopilot start using a rotated coordinate system. But in this problem, kind of look at it, right? What in what direction, along what axis is the acceleration happening? So what it's asking you is what does the force have to be on the wedge in order for the block to remain a constant height above the tabletop? So what that tells you is that there's no motion between the block and the wedge, right? There's no relative motion there. The block isn't slipping either up or down the wedge. So imagine if the force F you applied was too big, what would happen? The block would kind of slide up the wedge, right? If the force F you applied is too small, the block will slide down the wedge. So what it's asking for is like, what is that sweet spot of force that's applied there so the block can stay in place? And the whole enchilada is accelerating to the right. So that's a clue to us that we don't rotate this coordinate system. Okay, I'm going to leave the rest to you. Details are in the written solutions.